Hi, everyone. Welcome to our final project presentation with the Software for Climate program with Cloud.do. Our team is made up of myself, Jackie, and Philip, Daniel, and Alheli. We're presenting HydroCast for Data Center, a forecast-aware water risk app built for communities, policymakers, and operators. Our starting point was simple. Data center water demand is seasonal, and water stress is also seasonal and local. Static annual metrics such as WE, water use efficiency, miss that overlap. So we built a prototype that combines retrospective hydrologic analysis with near real-time streamflow drought forecasts, then translate those signals into a clear decision interface. Our project is grounded in a local problem. We started with a retrospective analysis based on water supply and demand for a Microsoft data center in west central Iowa. In West Des Moines, the basin matters, drought history matters, and timing matters. The same facility can face very different risk levels depending on whether a high demand month lands in a buffered summer or a low flow period. So our problem statement became, how do we make seasonal water risk legible early enough for real decisions? Our solution has 4 layers. First, we learn from the retrospective case study. Second, we add near real-time streamflow drought forecasts. Third, we translate those drought signals into scenario language that users can understand. And lastly, fourth, we present those results in an interface designed for action, not just observation. We designed HydroCast for data center around 3 user types. The community coalition wants evidence for advocacy. The planner wants a defensible place-based risk signal tied to policy levers. And the operator wants a fast read on near-term conditions and what they imply for preparedness. That user framing kept us from building just another dashboard. Our solution is based on the evidence. The figure here combines streamflow on the top, Palmer Drought Severity Index, PDSI, in the middle, and facility water use from 2022 to 2025 at the bottom. 3 patterns stand out. A demand peak are highly seasonal, and drought persisted for much of 2022 through 2024. And most consistent risk window is late summer into fall, especially when elevated water use overlaps with low flow. One of the strongest things about this project is that it genuinely uses what we learned in this class. Week 2 shaped our data strategy. Week 3 shaped the geospatial interface and our use of River DroughtCast. Week 4 helped us think in scenarios and constraints, and Week 5 helped us frame the app as an operational interface that connects real-world signals. This is the current prototype. Users explore the map by site. The dashboard then shows current streamflow conditions, the nearest forecast-enabled gauge, and a 13-week drought outlook. Our latest iteration adds confidence hatching plus 2 new interpretation panels, one for forecasted hydrological conditions and one for state-level policy context. To close, HydroCast for data centers is strongest when it moves from information to tailored action. Therefore, in the near term, that means clearer recommendation for different users. And in the medium term, It means automating data updates and scaling beyond a single case study. And in the long term, it means making forecast-aware water planning a standard part of digital infrastructure decisions. With that, I'd like to conclude my presentation and pass on my mic for Q&A. Thank you very much.